Hi. Now, in today's class, we would be looking into a topic that covers deviations from octet rule, right? Because till this time, till our previous lecture, we said that atoms, right? Atoms try to attain octet, right? That is, they try to attain 8 electrons in their outermost shell in order to attain stability, right? And we have seen in previous video lectures that some covalent molecules like nitrogen, oxygen, they always try to attain 8 electrons in their outermost shell, right? But there are certain covalent molecules in which the central atom does not contain 8 electrons, right? They contain either less than 8 electrons or more than 8 electrons, right? Less than 8 electrons we call it as incomplete octet, and more than 8 electrons we call this as expansion of octet or expanded octet, right? So let's look into the structure of those molecules, right, where this rule of octet is not followed, right? Or the molecules that contain the central atom of molecules, those contain either less than 8 electrons or more than 8 electrons, right? So the first example, okay, first thing, what this rule means: certain covalent molecules has in certain covalent molecules central atom has less than or more than 8 electrons, right? Right, so these have either less than or more than 8 electrons, right? When they have less than 8 electrons, we call it as less than 8 electrons. Let's write it like this: less than 8 electrons, we call it as incomplete octet, right? And when central atom possesses more than 8 electrons, right, more than 8 electrons, we call it as expansion of octet. Expansion of octet. Let's look at the structure of some molecules that has less than 8 electrons and some that has more than 8 electrons, right? So the first one is BeCl2, beryllium chloride. Beryllium has 2 electrons in the outermost shell, like this, right? And it has 2 chlorine atoms, and we know that chlorine atoms has 7 electrons in the valence shell, right? So here we will draw chlorine atoms like this. Let's represent the electrons of chlorine with X, right? Similarly here also, right? So chlorine will try to attain 8 electrons in the outermost orbit, right? So in order to attain 8 electrons, it needs to share 1 electron from beryllium atom. Same is with this chlorine atom. In order to attain 8 electron, it needs to share 1 electron with the beryllium atom, like this, right? So now if you see, both these chlorine atoms have 8 electrons: 1 2 3 4 5 6, 1 2 3 4 5 6, right? 7 8. Similarly 1 2 3 4 5 6 7 8. So both the chlorine atoms have 8 electrons each. But if you look at beryllium atom, the central beryllium atom, as per the rule of octet, this should also have 8 electrons, right? But if you count the number of electrons 2 electron, it has its own, right? 2 electrons belong to beryllium atom and 2 electron belong to shared pair. Now this shared pair, right, belongs to beryllium and chlorine. So it has 2 electrons due to this shared pair. Now this, due to this shared pair, it has 2 more electrons. So total electrons are 4 electrons, right? So central beryllium atom in BeCl2 has 4 electrons. That is incomplete octet, right? Now let's take the other example. Let's take the example of molecule that we are familiar with as NO, right? We know that nitrogen has 5 electrons in the outermost shell and oxygen has 6 electrons in the outermost shell, right? So oxygen needs 2 electrons more to complete its octet and nitrogen needs 3 electrons to complete its octet. Now let's see which one of these is incomplete octet. Nitrogen is like this. Similarly, oxygen, it's like this. Right? So oxygen will try to attain 8 electrons. It already has 6, so it will try to attain 2 more electrons. Right? It will take or share. It will share 2 electrons of nitrogen. Right? So this is the shared pair, right? This is the shared pair. Now this shared pair belong to nitrogen and oxygen, both nitrogen and oxygen. So let's see how many in NO molecule, how many electrons does nitrogen have and how many oxygen have. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. 8 oxygen, right? 8 electrons with oxygen atom, and with nitrogen 1, 2, 3, 4, 5, 6, 7. Nitrogen has 7 electrons, right? So here nitrogen has incomplete octet, right? Now let's look into some molecules that have expanded octets, that is molecules that have more than 8 electrons. First example that we would be taking is PCl5, phosphorus pentachloride, right? Phosphorus pentachloride, phosphorus have 5 electrons in the outermost shell, NH2NP3, right? The electronic configuration for phosphorus is, the outermost electronic configuration for phosphorus is 3s2 3p3, right? 3s2 3p3, and we know that chlorine always has 7 electrons in the outermost orbit. So let's draw the structure. This is phosphorus. Three, 4, 5. Right? And chlorine, also chlorine. Right. So chlorine 1, 2, 3, 4, 5. 7, right? Similarly here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Similarly this one 1, 2, 3, 4, 5, 6, 7. Right? Now sharing of electron will take place. Every chlorine atom will try to acquire 8 electron in its outermost shell. So all chlorine atoms have 7 electrons, so it will share 1 electron of phosphorus atom. Right? So this is how bonding will take place. Right? So all these represents the shared pair of electrons, right? And this shared pair now belong to phosphorus as well as chlorine. So let's look at this chlorine. How many electrons? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, all other chlorine atoms have 8 electrons in the outermost orbit. If you look at the phosphorus, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has more than 8 electrons. It has 10 electrons. This has 10 electrons, and each of the chlorine atoms have 8 electrons. Right? So looking at the structure of phosphorus pentachloride, we can see that phosphorus has expanded octet. Right? This is superoctet structure. We also call it a superoctet structure. So it has 10 electrons, that is it does not follow rule of octet, that is rule of 8 electrons in the outermost orbit, because it has an expanded octet of 10 electrons. Right? Now let's look at other example. We have one more molecule, sulfur hexafluoride, SF6. Right? SF6 molecule also does not follow the rule of octet. In sulfur hexafluoride molecule, this sulfur atom has 6 electrons in the outermost orbit, right? So since it has 6 electrons, and fluorine we know has 7 electrons in the outermost orbit, so fluorine will share again 1 electron from sulfur atom. All the fluorine atoms will share 1 electron from the sulfur atom in order to complete its octet, whereas let's see how many electron will end up on sulfur atom. Right, so let's draw the structure. Sulfur atom, right, sulfur, and we have 6 fluorine molecules. Right, it has 2, 3. It has 6 electrons in the outermost shell. Right, and it has SF6. The formula is SF6. SF6. And fluorine we know fluorine always has 7 electrons. Here 1, 2, 3, 4, 5, 6, 7. Similarly here 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. So this fluorine will share it has 7 electrons. So 1 electron it needs, it will borrow from sulfur atom. Right. Similarly, all fluorine atoms will borrow 1 electron from sulfur atom. Right, so now each of the fluorine atom has 8 electrons. Now let's see how many electrons sulfur has. 1, 2, 3, 4, 5, 6, 7, 8. Right, it has 12 electrons in the outermost orbit. Right, which is more than 8. Right, so this is how it does not follow the rule of octet. Right, so this is how we explain the formation of sulfur hexafluoride. Right, now we'll be looking into the reason as to what explanations were given. Right, so here we'll just mention the sulfur atom. Sulfur atom has 12 electrons. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, and each of the fluorine atom has 8 electrons. Right, so here sulfur does not follow the rule of octet, it has an expanded octet. Right, now let's look what explanations were given. Explanations for deviation from rule of octet. The first explanation that comes into picture was the Sugden's concept. Sugden's singlet linkages. We call it as Sugden's singlet linkages. What this concept says, that some of the bonds, right, in these molecules like phosphorus pentachlorides, some of the bonds does not contain 2 electrons, but it contains only 1 electron. So these type of bonds are 1 electron bond, right? Due to which it says that the central atom always maintain an octet. It always maintain an octet. And how does it maintain an octet? By having some bonds that have only single electrons, right? These bonds are known as singlet linkages. The central atoms are linked to other atoms using single electron bonds, right? So that's how it will maintain the rule of octet. So how will you draw the structure of this phosphorus? In that case, phosphorus pentachloride. The structure of phosphorus pentachloride will turn out to be, it will be like 2 of the phosphorus atoms, right? Suppose this is your phosphorus, this is your chlorine, right? And we know phosphorus has 5 electrons in the outermost orbit, right? And chlorine has 7 electrons. Right? Similarly, all chlorine atoms have 7 electrons in the outermost orbit. Right? Now let's see how will we draw the singlet linkages. Right? So it says it will maintain the octet, and how will this central atom maintain the octet? To some of these bonds, to some of these chlorine atoms, phosphorus atom would be linked by singlet linkages. Singlet linkages are 1 electron bond. Normally a bond, if I draw this line, in the previous video lecture we have seen that this line means 2 electrons, right? But in this case the explanation was given by Sugden that this phosphorus atom is linked to some atoms with singlet linkages, and this singlet linkage will contain only 1 electron, right? It will contain only 1 electron, and you will represent this bond with a half arrow, right? And it would be pointing from donor towards acceptor. It would be pointed from donor towards acceptor, right? So here, right, now this bond will contain only 1 electron, right? Here the electron of chlorine is not shared, right? Electron of chlorine is not shared with phosphorus. What it shows is that chlorine will share only the electron of with phosphorus, right? The chlorine will share 1 phosphorus electron to complete its octet, right? This chlorine will also share 1 electron from phosphorus to complete its octet, right? So if you represent it, we can represent it this way. This is chlorine, right? This is Cl, this is Cl, right? Now here we represent it like this, right? This means only 1 electron is shared, right, from phosphorus to chlorine in order to complete the octet of chlorine, right? So this half arrow represents the singlet linkage, and this is a 1 electron bond, right, pointing from donor towards acceptor. Donor is phosphorus in this case, right? So here we have singlet linkages, right? Singlet linkage is one electron bond, pointing from donor to acceptor, right? This is your Sugden's concept. Now there is another explanation to it. There is one more explanation for this, and that explanation is concept of overlapping of atomic orbitals, right? So according to the concept of overlapping of orbitals, atoms that can use vacant d orbitals, we know that some of the atoms have vacant d orbitals, right, in their electronic configuration, if you will see. So the atoms that have vacant d orbitals in their valence shell, those atoms, right, that have vacant d orbitals, they can use their valence shell for the expansion of octet, right? And since the elements of second period, if you look into the periodic table, the elements of second period do not have vacant d orbitals, right? So these do not show deviations from octet rule, right? So as per rule of overlapping orbitals, all those central atoms that have vacant d orbitals, right, they can use their vacant d orbitals to expand their octet, right, that is to have more than 8 electrons, right? So, and elements of second period, they do not have vacant d orbitals, right? So they cannot use d orbitals to expand their octet, so they don't have more than 8 electrons in any case, right? So rule of overlapping orbital says elements that have vacant d orbitals can expand their octet, right? Now there is third explanation for the deviations from octet rule, that is your Sidgwick's concept. As per Sidgwick's concept, the maximum covalency depends upon the period to which the element belongs. Maximum covalency of an element depends on the period, right? Period we are talking about periodic table, depends on the period to which it belongs. Right? So if it belongs to second period, it can have 4 electrons, right? It can show 4 covalency. And if it belongs to third period, right, or fourth period, it can show a maximum covalency of 6, right? And for those that have higher periods, right, for periods greater than 4, it should be equal to 8, right? For those in higher periods, it is equal to 8, right? So the maximum capacity of valence shell of an atom to have electrons, right, to have electrons for the elements mentioned above is this much. Right. So this is the Sidgwick's concept that says that it is not important, or it is not essential that that atoms should show maximum covalency of 8, right? The covalency of an element may exceed 4, and an octet can be exceeded 4, right? So the maximum covalency of an element depends on the period in which the element concerned is present, right? Like I said here. So the maximum covalency of an element depends on the period where it belongs. For hydrogen, it belongs to period 1. So it is 2. For element that belongs to second period, the covalency is 4. And for those that belong to third period, it is third and fourth period, it is 6. Right? So this is it. These are the explanations that were given. Here it only means that elements that belong to second period, it can have maximum covalency of 4. Right? Similarly, elements that belong to third period or fourth period, its maximum covalency is 6. Right? And it is not always essential that elements will show its maximum covalency. Right? For example, if an element belongs to 6th period, it should show maximum covalency of 12. But it is not always essential that the element will show its maximum covalency. It can show the less covalency also. Covalency is, we would be doing covalency in next video lecture. Covalency is, if you remember the formation of covalent bond, the number of electron pairs, right, that were shared, right, the number of electrons shared is called as the covalency. Like we did in electrovalency is the number of electrons transferred in the formation of electrovalent compound. So covalency is the number of electrons shared, right, to form covalent bonds. So this is it. We just need to remember some of the compounds, right, that in which the rule of octet is violated. It's BeCl2, right, like it has only 4 electrons in the central atom, right. NO, nitrogen atom, has 7 electrons only, right. Similarly in phosphorus we have 10 electrons, in sulfur, in SF6 we have 12 electrons, right. So explanation important was Sugden's concept, where it says that some of the central atom is linked to some of the atoms with singlet linkages. Singlet linkages means only one electron in the bond. There is only one electron, right? So in this case, the bonding is such that only phosphorus atom has shared its electron with chlorine atom, so that it can complete its octet, right? So this singlet linkage is shown with half arrow, pointing from donor towards acceptor. Right. The second rule, it says the rule of overlapping orbitals. That says that elements that have vacant orbitals, they can use their vacant orbitals, right, to expand their octet, right, and this is based on the covalency concept, right. So I hope this is clear. Thanks.